Hi, everybody, and welcome back to Chee-Tash. My name is Chris, and today I've got a special treat for you. We're going to be starting a brand new book today, just because I felt like I wanted to bring in something new. I wanted to bring in something that I do in my regular day job, and that's coding. I'm a software developer, and mainly I work in Java. I did some Golang. And JavaScript has always been something that has interested me. I've worked in it a little bit just personally on my own time and then this side project that I'm involved. But I've never quite grasped it. And my friend, a colleague of mine, actually gave me this book, Eloquent JavaScript, by Marijan Haverbeek, the third edition of this. And I would reference it from time to time, but one day I just sat down and I just started reading it. Just reading it line by line. And I thought to myself, you know what a great idea to do a series on this for the YouTube channel and for everybody out there. It seems like people are getting more and more interested in this. I did a coding boot camp. I feel like I hear about new coding boot camps happening recently. You know, they're popping up. I see lots of YouTube videos on it too. And I just thought that I would share in this experience and try to add some value to it. So we're going to be going through this book, Eloquent JavaScript, starting from chapter 1, values, types, and operators. And then we've got the IDE on the left-hand side. I'm using CodePen because it's pretty easy. The console's right down here, so we'll be able to see it right away. I'm sure maybe later we'll use some VS Code to show some stuff as well. So be on the lookout for that. And I'm sorry about this. We're gonna have to you're gonna have to work with me here. I want to show both the screens. I don't want to go back and forth, so I just have them both on my screen here. We'll have the PowerPoint on this side. Because this chapter is a lot about some theory. Okay, so we've got a lot about theory in this chapter, at least to start off, because Marijan starts off talking about basically how a computer works. A computer just reads and saves data. Reads, saves, writes data. And that data is stored in bits. And I'm kind of going to speed through this chapter. This is kind of a long chapter, and I'm going to try to get you guys out of here in less than an hour. We'll see how well I do with that. But a computer stores bits. So what are bits? Bits stands for binary digits. So zeros and ones. Just think about that. There's zeros and ones. So that's how information is represented on a computer. So when you type coding language, if you're over here and you're typing coding language, right? Well, this needs to be converted into those. Ultimately, it needs to be converted into those zeros and ones. How it does that? Well, you can look up that process. I know in Java, at least, it converts to, I believe, Java bytecode. It compiles down to that, and then from there to assembly or machine language, and that's how the computer is able to understand what you're doing, right? I don't know how it is in JavaScript. We'll have to take a look at that. Let's see. Does this do anything? Console. There we go. 6. Okay. Cool. So that's how a computer stores information. It's got to be converted into bits. So bits, how I think about this is if you come down here, so if you want to type the word 13 into bits, this would be the bit representation of it. So how this works, and we'll see this on the next slide here. So this is 13, 0, 0, 0, 0, 1, 1, 0, 0, right? Down at the bottom there, you see 2 to the nth place is what those numbers evaluate to. So start off like an array. You start off at the 0 index over here. If my mouse will go over there. There we go. So this is the 0 index. What's 2 to the 0 power? right? 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power, 8, and then so on and so forth, right? So think about every time you see a 0, it's off, 1 is on. And I think deep down, if you look into how a transistor or semiconductor works, which is, I think they're one and the same thing. It's essentially you're switching it into the on position if you want the 1, or the off position. It's like switches. They go back and forth. And I think before back in the early days, it was represented with a light bulb. So one light bulb turns on and then that one turns off, right? And that kind of, you can assume here that, okay, the light bulbs at the 8, 4, and 1 position are on, right? So that's how a computer would know. 13 here, if you guys look at this, 8 plus 4 plus 1, the evaluations on that bottom bar add up to 13. So that's what 13 is. So let me ask you guys this. What would be the representation for, let's do 15, right? 15, you would probably, it would just be 0, 0, 0, 0, 1, 1, 1, 1, right? Because if this is 13, you need to add 2 more to get to 15, so you would put a 1 here. You would turn this in the on position. And this is just kind of how my brain thinks about it. Maybe I'm not explaining it 100% correctly on how this all works at the most like basic computer level, right? But this is just how my brain is kind of thinking about it. Really great video from David Malman from Harvard, CS50. If you just look up that Harvard CS50, you'll probably see his video pop up, and he did a really good job of explaining this that like totally turned the light bulb on in my head. No pun intended there. So, okay, so the bits, it's not really going to help us. That's for the computer, right? So how do we transfer this information to the computer? Well, we do it by value. So like what I did over here. Can you guys see that over here? I'm wondering, can I? Oh, yes. Okay, there we go. There we go. Okay, that's probably much better for you guys. Values are where you separate the bits out in chunks and you assign values to variables. And so those values represent bits that the computer is going to interpret, right? So when you create a value, you just invoke its name. So here I assign the 6 value of a numeric type to this variable x. And then you can just reference the variable name to invoke the value. To create a value, just invoke its name. Well, okay, yeah, I might have just said that backwards, but to create this value, you invoke its name. So if I want a console.log, just print it to the console. Down here, excuse me, you would just call the variable name, right? So think about a value is what you assign to a variable. And that's not what Mergen necessarily wrote in here. That's kind of just how I think about it. And it's got to have a type. So we're going to talk about that in a second here. Types in JavaScript. There's number types, right? So number types, numeric values. A numeric value of 13 will cause the bit representation of that number. And I'm sorry, this is kind of butting up against this here. That's all right, I'll just scroll to the left. Will cause the bit representation of that number to be saved into memory on that computer. Look at that. So that's kind of what we did earlier, like previous slides ago. In JavaScript, 64 bits are used to represent a single number value. So think about it like this. Remember when we were going over the math there, 2 to the nth, and the n stands for that place, like that number bit in that number line, right? Let me go back to there. Here, remember? So 2 to the third place here is going to equal 8, right? So JavaScript uses 64 bits to represent a number. So think about it like this. You're going to have 64 places here. So 2 to the 64th possibilities, right? Whoops, there we go. It's a lot. I think in the book that he or she, Mergen, I'll just say Mergen. Mergen talks about how it's 18 quadrillion, I think it was. 18 quadrillion, it's a lot. It's a lot. I will mention this right now. We won't really get into this super specifically right now, but whole numbers are going to be different than fractional, than decimal numbers. All right, so the whole numbers are going to be precise, but fractional, you can't really rely on them to be precise values. JavaScript, I think, will cut those off at a certain point. So like 3.333, repeating, like, so what is that? 0.33, so 1/3. So yeah, 1 divided by 3, right? JavaScript's going to cut that off as a certain point, so it's not going to be totally precise because that just repeats forever, right? So even you cut off 1/3 at 0.333, maybe for your purposes it works, but you have to keep in mind it's not 100% accurate. So whole numbers, not all whole numbers less than this fit. So what do they mean by that? Let me read this from the chapter itself here. I'm right here. So for whole numbers, the actual maximum whole number that can be stored is more in the range of 9 quadrillion. So it's a little less. It's half. Or excuse me, not half. 9 quadrillion. And I said before 18 quintillion. Fractional numbers are written using a dot, but for very big or small numbers, you may also, Mergen talks about scientific notation here. We won't get into that just now. I just want to keep continuing on and rolling. This is all very introductory level stuff. Very important, don't get me wrong, but I don't want to get into the weeds yet on some of these things. So you have numeric values, right? Values can be operated on. Like a surgeon, you can operate on them. So the operators, pretty basic here. If you've taken any basic math, plus, minus, asterisk is times, / division, and then this percent sign, which is modulo. These are binary operators. So they're going to take two values, bits, binary digits, operators, binary operators. So it's going to take 2, right? So as you would suspect here, you can operate on these values, right? There we go. Addition, you add the 2 values. Now, you could also do this, right? You could do this, and this should evaluate it as well. Right? There we go. 12 and 12, right? But it would be advantageous to you to assign this to variables, and then that way you can just call the variables wherever you need them. Or you can reassign the variables wherever you need them. You can hide this implementation in the variables so you don't have to hard code this value, because this 6, maybe it might change, right? Maybe you're in a loop and you need an increment. You can still do it this way, I guess. You could still increment the 6. But this way it's nice and clean, and you're hiding the implementation of it. Not the implementation, but you're hiding the assignment of it. All right? You're hiding the assignment of it because these variables could very well change. Anyway, modulo. Modulo is an operator that tells you the remainder of. So it's kind of like division, but it'll tell you the remainder of if something doesn't quite go into something an even number of times. So here, if I do this 4 modulo 2. What is this going to yield here? It's going to yield 0. Why is that? Well, 2 goes into 4 2 times, 0 remaining. That's what modulo evaluates. 2. It evaluates the remainder of the division. Just think about it like that. So what would this be? 5 modulo 2. Let me put a space in here just aesthetically. If you said 1, you are correct because 2 goes into 5 how many times? Twice. What is that? That's 4. Okay. What's remaining once you subtract 5 by 4? 1. So you get the 1 here. All right, same thing. Look at the slide. 16 modulo 5 is going to be 1. Same thing. 3 times 5, 15. Goes into that 16 once with 1 remaining to get 16, the whole number. And I'm sorry I'm going over this a little fast. But let me know anytime, guys. Let me know if you have questions in the comments. We can discuss this at any time. I'll make myself available to answer any questions. Modulo is a very common thing that's used to tell if you have even numbers, right? Because if something goes into something else evenly, that with no remainder, then you know it's an even number. Particularly 2. Only, I don't want to say only 2, but 2 is like the smallest even number. So it's very popular to modulo something by 2. And then if you get a remainder of 0, you know that that number is an even number, right? Very common on interview questions. I got asked on this on a coding interview that I did for the current project that I'm working on. So common. FizzBuzz challenge too. I'm pretty sure they use this as well. So just something to think about there. Special numbers. I'm not going to get into these. Infinity, negative infinity, not a number. Special numbers, basically when you'll get this, especially the NaN, when a calculation does not yield a meaningful result. I have gotten a not a number before. I have. Let's see what happens when you do this. Oh boy. Uncaught reference, infinity is not defined. Oh, is it a capital? Look at that. Is it capital? I never knew that if it was. Show me. There you go. Not a number. It's not a meaningful result. Or, you know, if you do, this would probably be more apropos. Infinity plus infinity is equal to infinity. Okay. It's the minus. Okay. So when it does not yield a meaningful result. What's a meaningful result? You know, I don't know. I mean, something that probably is something really, really small or really, really big. Something along those lines, really, really small or really, really big, or you're trying to operate on infinities. You're going to get not a number. It's going to say, hey, why are you working with infinities here? Now, interesting thing, let's try this. Console.log type of infinity. I am curious here to what this evaluates to. Number. Okay. Yep. So same thing if you were to do NaN here, it still evaluates to a number. It's a special number, but it's still a number. Yeah. Okay. Even that evaluates to a number as well. Let's continue on. Next slide. There we go. Strings. So there's numbers and strings. A lot different than in Java, where in Java you have primitive types and you have different types of numbers, right? You have ints, you have shorts, you have bytes, you have doubles, longs. Am I forgetting one? Double? I said double. Yeah, I think that's all of them. Yeah, I think so. In JavaScript, you don't have to declare the type, right? When you instantiate the variable here, like we did up here. in Java, you would have to say, int y equals 6, right? You would have to say that. See, and it's yelling at me because this is JavaScript. But in JavaScript, you don't do that. You don't do that. It knows by the fact that there's no double quotes, double single quote, or backticks. I'm trying to, there we go. That's fine. So strings are text, used to represent text. And you can do it in a few different ways. You can do it with single quotes, double quotes, or these backticks. And those backticks are really slick in JavaScript. We'll do an example of that. So there we go. Hello. If you did this, I mean, it's not going to make a difference. You can do it in double quotes too, and it'll still say hello down here. One thing I would say is just, I try to be consistent. If I'm using single quotes to represent strings around my text, I try to do it in the whole file, in the whole project. I don't like to mix and match. If I do string there, and then I do let string 2 equal, right? I don't like to mix and match them. That's just me, though. Next bullet point there, modeled as a series of bits, just like numbers. So there's something called Unicode, which assigns a number value to these letters, to these characters. And you can actually look this up. I'm not going to spend too much time on this, but you can look it up. Yep, look at this. Look at this massive thing. So it assigns a number value. Oh, gosh. It assigns a number value to the letter. And then from there, that number value, you can then find the bits, what it represents in bits. And holy cow. So look at that. Octodecimal. Oh, well, thanks. That's not really what oh, okay, yeah, here's the letters. So there you see capital A, different than lowercase a. Look at that. Hexadecimal, the octal, the decimal 97, 65. So there's the binary digit representation of that. This is 65, so that's it. JavaScript will know. It's going to know if you're representing a string just when you put the quotes around it. Because that's what I was a little confused on, is how does it know? Because this binary digit here, this binary code here represents a number too, right? Right, that's going to represent a number. How does the computer know that this is capital A and not 65? And I think it's because of the quotes around it, I believe. So let me go back to CodePen. You can escape characters. So basically escape characters means that you want them to be incorporated into the string. So how should I do this? Console.log. If I want to print out a quote, right? I want to print out a quote. You have to escape the quote. You have to escape the quote. And look, so it prints off the quote there, that single quote. Now that's interesting. I wonder why it prints a single quote. That is not what I wanted you to do. There we go. What will this print? Okay, so that prints the single quote too. God, that is interesting that it... Yeah. Sorry, I just want to check. Is this going to do a single quote again? Okay, so it does the single quote. That's very interesting. But you see there if I didn't include that backslash, it wouldn't print that. So you can do the same for other escaped characters like a new line. So what if I did this? What's going to happen? So here we go. Hello plus new line plus hello again. So it escapes it. It goes to a new line. The backslash T over here is a new tab. So you can do that too. Let's continue forward. I think we're going to talk about the backticks and yes, the template literal. So here, this is an example of concatenation, this line here. You combine strings together, right? And let me do the most basic one here. Hello. Plus hello again. So you're going to combine them. Look at that. They get glued together, as Mergen talks about it in the book. Now, one thing I'll say, when you concatenate, just be mindful of the spaces. Look at how that combines it right up against the comma. Well, because you didn't include a space there. Now I include the space. Now that looks like a little bit better of a sentence. So just something to keep in mind when you are coding in concatenating strings. Just being mindful of that. I know this might come up if you're trying to generate comma-separated values and strings into a huge string, a comma-separated value string, and then you want to break it off into an array. Just be mindful of the spaces. So we have these template literals, right? Hello world plus $. And then watch this. So 50 divided by 2, like in the example, right? Now, if I console.log this out, essentially what a template literal is, this $, and then the brackets, right? It is essentially injecting JavaScript into the string. And I did this incorrectly. There we go. Make sure you use the backticks. There we go. There it is. And then actually you'll see the code color should change a little bit there. I'm surprised. Sometimes the brackets change color too, but it's not doing it in CodePen. I think it does it in VS Code. But essentially, you're injecting JavaScript into here. You're injecting JavaScript into here. So this expression is going to get evaluated, and then this whole string, it's going to get added to the string. So if you print this out, hello world 25, right? I've seen this used in HTML when you're looping through a list, and the variable, like if you're doing like a for each loop, the variable that, let me see if I can do one for you guys here. For let x equal 0, we're going to go until x is less than 4, and we're going to increment x, bada bing. Every time we loop, I want to include in that template literal. I want to include in this template, this is very touchy, CodePen is. I want to include, what do I want to include? I'm going to include x. So watch what happens. If only there were a way. There we go. This is kind of hard to see, I know, guys, but Hello World 3, you can see Hello World 1, Hello World 0 is up at the top. I'm really sorry, that's hard to see, but you can see that the variable, right, you're injecting the variable into this string, right, and then it's going to loop through. We're going to talk about loops later, and it's going to print that the template variable that you're assigning this template literal to, this string to. So it's a way to inject JavaScript into a string. Because you don't know what this X might be, right? You might not know sometimes. But whatever, so it's better than hard coding it, because hard coding it might work in one instance, but then you'll need it to work in another instance. It's going to be hard coded. It's going to be tough to change at runtime. But here, you're just saying, hey, whatever X evaluates to, just do it to that. Evaluates to, assign it to that, put it in this template literal, and you're good to go. Let's continue on, guys. What are we at? Unary operators. So binary operators. Then there's unary operators. And I think I showed you guys one earlier, this type of operator, right? Type of. So it only takes one value. And it's usually written in words. Besides this, minus sign can be used as both a unary and binary operator. There's also the exclamation point. We're going to get to that in a second here. But type of, that can be useful, right? So God, this code pen's really touchy. Wow. Type of template. This should print string. Yes, sir. So just something else that you can use to operate on used to operate on values. I'm sure this would come in handy at some point to know the type of a certain variable. Maybe if you're doing classes too, it'd be good to know what type of variable. Maybe you're doing some object work. Let's continue on. What do we got here? Boolean values. Yes. Boolean values. God, this is so touchy, guys. So yes, thank you. Boolean values. Evaluate to true or false. Less than, greater than, less than, equal to, greater than, equal to, equals, equals, triple equals, right? What do those mean? We'll get to that in a second. And then the not equals, that's what the exclamation point is. So if I were to do console.log, 5 does not equal 6, what's this going to evaluate to? True. Because it doesn't equal 6, right? 5 does not equal 5. False. It does equal 5. 5 greater than 5? False. But 5 greater than equal to 5? True. There you go. So just keep that in mind. Keep these in mind, as you, especially in loops, when you want to iterate a certain amount of times. We'll talk about this later when we go into loops, but essentially Boolean operators, Boolean values evaluate to true or false. And it doesn't have to be used with numbers either. I mean, this can be used with strings. So as you can see there with aardvark and Zoroaster, I don't know what that is, but it sounds pretty cool. If I were to do A is less than or equal to A, should be true, right? It's true. Now, what do you think this will be? False. Oh, no, true. Yes. No, that's correct. Based on, do I still have it up? Yeah, there you go. So A, remember it gets assigned a Unicode value. So A, 65, small a, 97. And what did we put? Big A, less than. That is true. Less than or equal to? That is true. So if you have longer strings, just look at the rules over here on the PowerPoint here, guys. If I can move over just, that was a little too much. Come back. There we go. So it compares letter by letter starting at the first index. So the first letter, it's going to compare the A and the Z, big A and big Z. If the first character's Unicode value is less than, or whatever operator you're using here, then you're finished. Then you know that this is true, right? But if they're the same, it's going to go to the next letter, and then the next letter, and then the next letter. If both strings at the end are the same length, and they're all equal, right? To get to the last letter, all of the previous ones had to be equal. Well, then the strings are equal, right? So this would be false. In this case, if they were the same length and yada yada. So for longer strings, right? So if let's do this example. A, it's like that. This will be false, right? Because this is the longer string. Is the longer string less than the shorter string? No, it's longer, it's greater. So this will be false. That's kind of basically what the rules we are setting here. Oh boy, next we got the logical operators. All right, now we're getting into some weeds. The logical operators, how would I describe this? Basically, they're binary operators in which both sides or one side have to evaluate to true. Or no, that's not a good way to describe it. The logical operators. So essentially, logical operators take Boolean values, right? And they manipulate Boolean values. Maybe that's a better way to put it. Or they manipulate what Boolean value you see. That's an even better way to do it. I really like the way that I described that there. They manipulate the Boolean value you see. So true and true. What's this going to print? Let me spoil you here. It's going to print true, right? It's going to print true. Because it's true, this will evaluate to true if both values on both sides are true. As soon as you make one false, it'll all be false. It's going to print false. There you go. Now the OR will evaluate to true if just one side is true, and that's represented by the pipes, the double pipes. So false and true, it's still going to be true. It's still going to print out true here because one side is true. Okay, now let's get crazy. This not operator flips the value given to it. So remember that definition I just gave you. I really like that definition. It manipulates the Boolean value you see or you use, right? So false, right? We're giving it false, but the not operator, unary operator, is going to flip that Boolean value. So false, not false is going to be true, right? Right? I mean, it's going to be true. So now this prints true because at least one of them is true. Now watch this. Ampersand. This also prints true too. Because both are true now. Not false is true, right? So there is some precedence, just like there's precedence in the binary operators, plus, minus, times, division, right? Please excuse my dear Aunt Sally. That's what we always think about for the binary typical arithmetic operators. Please represents parentheses, excuse, I think that's exponent, my dear, multiplication, division, and Sally, addition, subtraction. So parentheses, greater than all. And it's the same thing with the logical operators. The pipes take precedence over the ands, which take precedence over the comparison operators, the Boolean operators, values there. Next up, empty values, null and undefined. Null and undefined. Absence of a meaningful value. They really don't carry a lot of information. And some operations are going to yield an undefined. I don't know if any are going to yield a null unless, like, if you go into a database and you grab something from a cell that's empty, that might give you a null. I think it would give you a null. Might give you an undefined though as well. Marigin kind of talks about treating these kind of similar, kind of like they're the same thing. Not a huge difference between the two. So, I mean, literally let null equal null. You're not going to be able to do this. You know why? Because null's a keyword. I don't think you're going to be able to do this. Yeah, it's going to tell me there's an error because null is a keyword. Unexpected token null. Yep. Jeez. CodePen is so touchy. Have I mentioned that today? Let z equal null. Obviously. And then print out z. It's still going to print out null. Okay. Next slide. What are we talking about? Automatic type conversion. Type coercion. So what is this? JS will convert the value to the type it needs when an operator is applied to the wrong value. Okay. So what does this mean? It's gonna, and this is really tricky because it does something different, as you guys can see here, from a minus to an addition. Right? 8 times null is going to evaluate to 0 because it's going to treat the null like a 0. But I am curious, what if we do this? If it really is treating the null like a 0 here, I am really curious. 8 times parentheses. This is going to get evaluated first, right? What is this? Does this evaluate to anything? I am just super curious. 8. Okay, so very interesting. So type coercion. It's going to convert it to the type it needs. So null, empty value. 1, numeric value. It's going to convert it to a numeric value. So null ends up becoming 0. I've seen this happen before in JavaScript code. It's going to convert to 0 if that's what the code needs it to do. 1 plus 0 is 1. 8 times 1 is 8. Cool. Cool, you say. What about this? What about this? Is this going to be legal? Kind of like you see on the third bullet point in the code. Is this going to be legal? God, that's so weird. Let's make this simpler. What does this evaluate to? 851. Very interesting. So what does it do here? It converts the numeric value to a string. It's going to concatenate. 5 plus 1, you're thinking it's 6, but it's not. It's 51. It's going to turn the 1 into a string and then combine it together. Then it's going to do the same thing with the 8. Turn the 8 into a string and then combine it together. So 8 is before the 5 and the 1, so it's going to add it to the top, as you can see here. 851, string representation of 851. But something different happens when you subtract. Interesting. When you subtract, it converts the string to a number, so it's kind of like the opposite. So 5, number 5 minus 1 is 4. 8 plus 4, 12. Very, very interesting. And now take a look over here, guys. 5 times 2. Intuitively, you're thinking 10, right? But string representation here. But it's not, it can't be converted to a number. 5 written out? No. Now, it'd be one thing if it was not written out, if it was literally the numerical digit 5 here times 2. What does this yield? I'm just curious. Does that seriously not yield anything? Come on. I guess it doesn't yield anything. Okay, that's good to know. Very good to know. That's why here you're going to get not a number, right? And then sometimes, you know, these, anytime you see a 0 or let's see if it does it with null here. It might convert it. Nope, it didn't do it. Okay. I typed too fast. Show me. No. Oh my god, I'm sorry guys. Console. There we go. Jeez. What does this evaluate to? Jeez. CodePen. Stop. False. Is false equal to null? It's not. Okay, so I don't think nulls will convert, but a 0 will convert. It'll treat it as false. JavaScript reads this as false. It'll convert it to like that type. That's what the double equals is, and that's why it's different than the triple equals. There we go. When types differ on both sides, JS will try and convert one of the sides to the other. Does this do anything to you? It's going to be false, right? It's going to be false. Empty string might be true. True. So it's going to read the empty string as a false. Right? It's going to read the 0 as a false. It tries to convert the type. So what if I had, let's see here, 1? It's going to be false, right? What about is 1 less than 0? Will it convert? It's still false. What if it's greater than 0? True, right? So it converted. It converted. Did it convert the 1? Let's see here. False. Is 1 greater than 1? It's not. Okay. So it converted on the one side to what the type on the other side was. Right, so that's what the double equals does. Yes, you can still use this to compare if like things are equal, but if it's not the same type, then it's going to convert to that type. It's going to convert to that type. So 5 is equal to 5. Does this still ring true? That still rings true. This 5 greater than 5. False. That is correct. Is 5 less than 5? It's not. It's greater than or equal to 5. This should be true. Okay. And look at that bullet point that I wrote over here, guys. When null or undefined only will produce true if both sides are null or undefined. Okay, so that explains why when we did false equals null, it evaluated to false. Right. So now triple equals and then not equals. So not equals, this is going to evaluate to false. Because when it converts them to the same type, they are equal. So when you use triple equals, it's used to check precisely true. So it's not going to do the type coercion. 0, that's why when we saw this, guys, when we did the false equals the empty string, this evaluates to true. Right? Because of type coercion. But when you do the triple equals, it's going to be false. Boom, as you can see there in the console. Because there is no type coercion. It's comparing the precise values. Let's continue forward. Oh, yes, last slide. We're going to get you guys here out of here in under an hour. Hopefully, still. Short-circuiting of logical operators. All right, so short-circuiting. Oh, gosh. I hope I know what this is. Because I really haven't really used this. So an OR. OR will return the value to its left when it can be converted. I got to shorten this for you guys. I'm so sorry. I just need to be able to read the whole thing. or will return the value to its left when it can be converted to true, else it will return the value to its right. And then the ampersand works in the opposite way. Returns the value to its left when it can be converted to something false, else it will return the value to its right. So in this instance, x will never be evaluated in this case. Let's set something up here. Let's set something up here. So, yes, okay. Yep. True or 5 less than 1. Okay. Now, you know what? Because that's not really representing short circuiting. Let's do this. Let example equal to 5 greater than 1 or 6 less than 5. Console.log example. So we're going to do this as an assignment. So what happened here? Why did this get evaluated to true and not to false? Well, this side of the operator is true. So it's just going to assign it that variable, right? Because we're printing it here. You can see it's true. The other side doesn't even get touched. Now, if this were 5 less than 1, right? So 5 is 5 less than 1? It's not. Is 6 less than 5? It's not. So it's going to get assigned false. But is 6 greater than 5? It's going to get assigned to true, and then you're going to print it there. I have seen this used. In assigning variables before. And remember what it was saying. The ampersand is different, right? The ampersand, totally different. So if the pipe works, it will return the value to its left when it can be converted to true. For the ampersand, returns the value to its left when it can be converted to false, right? So this value converted to false, it's going to return that. False. That's why we get false here. So it evaluates this side, doesn't even touch that side because this side is false. And that's how you short circuit logical operators. And boom, guys, that's going to do it for episode 1, Eloquent JavaScript. I know I went through this fast. I was trying to hit the bullet points, give you guys some coding examples over here. Hopefully this helps, the coding examples. And once we actually start like building things, you'll see why some of this stuff will be important. If I went too fast and you have questions, please leave them in the comments section. I look forward to your questions and dissecting issues, learning new things. So let me know what you think. Please like and subscribe to the videos. There's going to be more from Eloquent JavaScript coming along. And thank you guys so much. My name is Chris. This has been Chee-Tash. Take care.